Hello, everybody. This is Professor Ma, and welcome to the section on first degree equations. Okay. We call a function is a procedure that produce one output for each input, only one. And we in mathematics, there are basically three classes of functions. The algebraic ones, these are the functions like polynomials and fractions, rational formulas, and trigonometry families, and they are related to triangular measurements. And of course, then we have log and exponential functions. And basically, in mathematics, we have these three family of functions, and then we compose one with another and add and all the operations to make up most of the formula you see in calculus books. Okay, and the first degree and the second degree functions like that are the most important ones, both in mathematics and physics. And these, if you look at your calculator, these are precisely on the calculator. This is the Microsoft desktop calculator. Then these are the three families. In every calculator, you will see these blocks, trig families, and this block is algebraic families. And then, of course, over here are the log and exponential, the three families. Okay. So we are going to now look at linear functions, okay? And to do that, let's first start with linear equation. That's a formula where x's and y mixed together. You don't, not particular designated which one's the input, which one's the output. But you can plot them and graph them, okay? And to graph an equation like that, for example, if I have this one, then the easiest way to graph is plot the intercept. The reason because these equations, the graph of them are all lines, okay? And so I plot the intercept of this. I'm going to plot 2 points. And the easiest way to plot 2 points is set x0. So if I put x0, this is gone. Now y is equal to -4. And what I have is a point over here, 0 minus 4, which is the y-intercept. And that's 1 point. And then I do it the other way around. I put put y equal to 0, and then solve for x. Then this one will give you x equal to 6. And then we have the points y0 and x is 6. And these are two intercepts. Since the graph is a line, so that's a graph. Okay, so, and then another case is where actually another 2 cases which are quite different is where in this case the x is not in the equation. So in other words, this equation y is -4. So if you plot the points where the y coordinate is -4, points and 0 -4, 6 -4. We have points down here, and so that's a horizontal line, okay? Y is -4 translate into the position of the point. It's 4 below the x-axis, okay? So that's what this horizontal line. And then we have the case where y is missing, you only have x, then you have the equations, x has to be 6 in this case. So it could be 6, 0. It could be 6, 6, you know, as long as x is 6, it's a point on this straight line. So this is a vertical line that going through up and down at x equal to 6. Okay, so these are 3 different types of these linear equations. Of these 3 different types, these 2 are functions. Meaning what? Meaning because there's a y in there, I can solve for y. I can put this formula in a particular form. That's not a function. Remember, you can have a graph of a function that go up and down, but hits more than 2 points, 2 or more points. So as long as the number in front of y is not 0, I can solve for y. And if I solve for y, I'm going to write a formula, the first degree functions in this format, which is a straight line. y with the y the term y present. Okay, this is called a slope intercept form. Okay, because the number m in the front is called a slope, and the number b is the intercept. Okay. And so, for example, here is a linear equations, and this is a function. I can put them put into slope intercept form and turn this into a function. Now I can interpret this as y is a function in x, and is 2/3 of x minus 4. Okay, so, and in this case, as these functions, linear function, the slope of this function is numbers 2/3. And of course, y-intercept is minus 4. And for the other one, x missing, if I solve this for x, I solve for y, I get 0x. So the slope of this one is 0. Okay, so in other words, this function has a slope. The slope is 0. But the equation 2x equal to 12, there's no y, so there's no output. So this just has to say so the slope is not defined, and so this is not a function. So there's no function form for the vertical lines. Okay, so we have these two forms of linear equation that are functions, which we can put into this format. Okay. The slope we'll see later on. It's the change in the input causes how much change in the output, the ratio of the output to the input. Okay, and that's actually the slope. And we can take a look at it from the graph. Okay, so these pictures and formula basically tells connect all the graph and algebra together. So suppose I have 2 points. We're talking about straight lines. If I know 2 points on a straight line, and this is a functions because it's not up and down vertical, so I can calculate the slope, and the slope of this is given in these forms, and there are 3 different forms. And first one is delta y over delta x. Delta y is the change, the difference in the y's, okay, and what y's? The y's in the coordinates. The height of one point versus the height of the other point, how much rise is from one to the other. And then the denominator is dx is the run. Horizontally, that is how much displacement is going from one point to the other point. And then you take the ratio of these two numbers, delta y divided by delta x, or rise over run, another way to say it. Or if I use the explicit formula, that's the formula. So it's this ratio between the change in the height versus to the change in the horizontal distance. Okay. And once we know the slope of a line on the picture, and calculate one way or the other is given, or calculate from the equation like that, then I can produce the equations for this line, functions equation for this line. Okay. And here is the formula. The formula is called the point slope formula. So the point slope formula produce a function, a linear equation that pass through certain points or with certain slope. And these are linear equation, we call that straight lines. So here's some examples. Here's an example of why I tell you the slope of the line and tell you where the y-intercept is. The y-intercept, basically, I'm telling you with a point, 1 point, okay, is 0, 3. And that's precisely what point slope formula requires. It requires a slope at a point. Once I have that, then I can make the equations. Put -2 in the front, x, then put zeros over here, -0, and then plus the 3. Whatever the sign is, you put 3 in there. And this is the equations for the line passing through 0, 3, slope -2, okay? And slope -2 means if I look at 2 points on this line, and I take the height, okay, and divided by the run, and this is 2 to 1. Okay, this is the red line is twice as high as the blue line. Okay, so that's geometrical interpretations of the slope. It's negative because it's pointing in that direction, from the second to the fourth, between second and fourth, connect between the second and fourth quadrant. Okay, here is part B. I don't know the slope, but I have points. So what I need to get the slope. So what I do is this one, I use a slope formula, delta y minus delta x divided by delta x, the y, subtract y divided by subtract of the x, it comes out to be 2. So here the slope is 2. And I know a point. So I'm going to use a 0.53 and the slope 2 to make the equations. And so I can do that one more time. Put the 2 in the front, put x here, minus the x 5. Since the 3 is plus, that's plus 3. Okay. If you use this point, you check, you want to know the same equation after clean up. After clean it up, 2x minus 7. And then the third case over here, x-intercept by 3 and contain the point 3, 4. This is a line that's vertical, so it's not a function. So it does not have a formula like y is equal to something like that. It doesn't have a y. This one has the equation x equals 3. It's not a function. Okay, it has undefined slope. Okay, and make sure you know the difference between slopes undefined for a vertical line versus slope is 0, a horizontal line. Okay, and so these are linear equations, and we use these. These are actually something which down the history human being has tried to use this method to make educated guess. Okay, for example, here's an examples that you will probably, if you travel, you go to some city that next to a river, a lot of times you will see a mark of the rock or some kind of sticks that tells you that when is the highest level of waters doing flooding, how much did it get up to, the highest historically. So there's a river floods regularly at the time, and there's a rock that has a line on top of it. So on July 11th, 12 o'clock, and water is coming up, and here's a mark, and here's water. We measure the water level is 28 inches below the mark. Okay, and the water is coming up. So we go back next day, 12, at 8 o'clock in the morning. Okay, and then we look at the water again, and now the water crept up. Okay, instead of 28 inches, now it's only 18 inches from the top. Okay, so the questions ask, say, well, let's let x be number of hours, let x be the time. And let y be the distance to the top mark. Okay, write these as a function, a linear functions in x, y equal to f of x is equal to what? Okay, if I tell you the time, tell me what's the distance supposed to be. Make an educated guess using these two measurements. Okay. So here's what we do. X be the time, y is the distance between the water level and the mark, and then we want to find the functions that tell me the distance depending on the times. And a couple of things we can do. The first thing is this time, this is general in science. The time on your clock is 12 o'clock, 8 o'clock. But when you do this equation and calculation, I can reset my clock to 0, and at 8 o'clock next day, that's 20 hours later, 12 hours plus another 8. So instead of calling them 12 and 8, I will set them to be 0 and 20. First, adjust the time. So make the calculation a lot easier. Okay. So on what we have basically is a 0 hour, distance 28 inches. At 20th hour, the distance 18 inches. Okay. These are called paired data, and these happen. We have these a lot in mathematics. That's at a particular time you measurement, another time you measure again. For instance, you're boiling water on a stove. At time 0 is 24 degrees Celsius. 2 minutes later, it's 85 degrees. It goes up. So we got two measurements. At time 0 is the temperature 25 degrees, and time 3 minutes later is 75 degrees. I mean, you got a pair. These are called paired data. What can we do with paired data? We can make a line, and we can use the line to do estimations. Okay, or educated guess. So in this case, we want to find the slope of this line, delta y over delta x. So slope is minus 1/2. What does this 1/2 means? Okay, here xy, x is hour, y is distance. And this minus 1/2 means minus 1/2 for the y, we say inches. Okay, it's delta y, remember? Per 1 hour. Okay, inch. In other words, the water level is rising, so the distance shortened by 1/2 inch every hour. That's what a slope means. It's a per unit change for the output when you put in 1 extra unit of input. Okay, if I increase the input by 1, how much change in the output? In this case, the change in the output is 1/2 inch. In fact, negative 1/2 inch. This I can write the equation very easily. Put the minus 1/2 in the front and use a point 0, 28, 0 goes here, 28 goes there, and there we go. So we have a functions. This function predicts the distance from the water level to the high mark. What can we use it for? For example, at 8 a.m., remember at 8 a.m., the distance measurement was 18 inches. Okay. Now, if I were to extrapolate from this, I think so. What happens if I wait for another till 4 o'clock in the afternoon, after 8 hours? Okay, let's at 4 p.m. What should the measurement be? Well, at 4 p.m., x is what? X is going to be up to here is 28 at 8 a.m. 20, sorry. And so at 4 p.m., that's 8 hours later. So x is 28 at 4 p.m. So I can plug in 28 into these equations. Y 28 hours later minus 28 over 2 plus 28, and I wind up with y is equal to 14. 14 what? 14 inches. In other words, I expect to see the water level at 14 inches according to this formula, educated guess extrapolation from 2 data points. And at 4 p.m., I go measures. Okay, this is measurable. I can go 4 p.m. and suppose I measure 12 inches. And what does it tell us? Oh, it tells us the water is actually rising. It's rising faster and faster. It's not rising at a steady rate. It's rising in a curve. It's increasing, it's going faster and faster, right? So the flooding is getting quote unquote worse, colloquially. Okay. And this line in mathematics we call a trend line. Okay, it tells you what the trend is. Okay, so from this you can deduce what the trend is going to be. Educated guess. Again, only using 2 data points. Okay. So from this we can conclude the flooding is getting worse. More facts about slope. parallel lines have the same slopes. Perpendicular has negative reciprocal slopes. So for example, okay, I have a line, let's say this line, the slope of this line is 2/3. I have another line down here, equation, and it has its own equations. Okay, and then the slope of this one is also 2/3, as long as they're parallel. In other words, if I write this equation as y is equal to 2/3 x plus some number, and this one the same thing, y is equal to 2/3 x plus some other number, because they're different, they're shifted. Okay, so these are for parallel line. On the other hand, suppose I have a line that's perpendicular to this one, 90 degrees. In mathematics, in physics, we consider the perpendicular direction very often. Like for instance, how a force breaks up into two different component force. In mathematics, we have the perpendicular, for instance, in the case of when we go to three-dimensional surface, the things that's perpendicular to the surface. All these are very important mathematical tools. So these are actually important facts that we do use in mathematics. In other words, that what's the slope of this green line that's perpendicular? Well, it's the negative reciprocal. So I reciprocated and changed the sign. Okay, negative reciprocal means flip, switch sign. That's the relationship between the slope of perpendicular line. So here's an example. Here I have a point, a line goes through that point, and that line is perpendicular to another line, which is given. So I have equation of a line. Remember, what do we need to get the equation? I need a point and a line, and I have a point. I need a slope and a point. I don't have the slope, but I can infer the slope from the line it's perpendicular to. This line, I can calculate the slope. So I calculate the slope of this one, 4x is -5 equal to 3y divided by 3. I only want the slopes, 4/3 x minus 5. So I don't care about this one. I want 5, 4/3. Slope of this is 3/4, but mine is perpendicular to slope 4/3. So for my, so these equations that we refer to, this line we refer to, the slope is equal to the negative reciprocal -3/4. Okay. And once I have the slope, I have a point that I can write out the equation y is equal to -3/4 x. Put the 2 over here, minus the 2, then plus the -4. Okay, or just plain -4. So this is the equation satisfy these conditions. So again, solve for y, and I can extract the slope. Then I negate negative, make the reciprocal. That's the slope I want for my line. And then I can use these to build my line, the equation, the four functions for my line. Okay, and that's it. So this is how we'll do with the equation and lines and graphing for first degree functions. Okay, bye-bye. Bye-bye.